Could you tell us about who you are?
Yeah, I'm Katya Arquilla, and I'm currently a postdoc associate at MIT in the Department of Aeronautics and Astronautics. So I just finished my PhD in aerospace engineering sciences at the University of Colorado Boulder. My research focus is in bioastronautics, which is the study and support of life in space. And in the position I'm in now, I'm both continuing some of the work that I did during my PhD and expanding into new areas of research.
Mhm. So how did you make the transition between astrophysics and aerospace engineering?
Yeah, I think a lot of the skills that I learned during my undergraduate studies in astrophysics transferred really well into aerospace engineering. In my research area in particular, most of the studies that we conduct require a bit more of the basic science approach than an engineering approach. So having that background has really helped me in that sense. Functionally, I took time to work before I started grad school after my undergraduate degree. And during that time, I got to explore different options, look at what was out there, and found that the bioastronautics research area aligned really well with my interests.
Mm-hmm. So why did you want to switch to aerospace engineering?
So I've always been interested in space. That's why I started going to school for astrophysics, because I thought that was the best way for me to study space. But along the way, I found that I was really fascinated by humans and specifically by human behavior. And there's really no more extreme environment than space to study human behavior. And this is what really caught my attention with aerospace engineering the most. When I was young, when I was in high school, I didn't really know what aerospace engineering was or that it was a thing that I could study. Actually, it wasn't even until later in college that I figured out that that was the field I should be working in. So I'm glad you're doing what you're doing here and exposing more young people to the possibilities out there, because I definitely didn't really know where my passion would fit. And so this is a cool thing.
All right. So what's the difference between aeronautics and astronautics versus aerospace engineering?
Yeah, so as far as I know, these are functionally the same thing. Some schools call their programs aeronautics and astronautics. Some call them aerospace engineering, but usually both types of departments are housed in the engineering school at a given university. I think it maybe depends on when the program was founded and what it was called at the time. Some of the newer programs are aerospace engineering and some of the older ones are aeronautics and astronautics. But I don't think that's necessarily a hard and fast rule. But yeah, they usually have the same research focus areas, the same type of stuff going on. So I think that functionally they're the same thing.
Mm-hmm. So you published a paper about the interaction of spacesuit and its wearer. Could you explain what challenge your study on spacesuit interaction will solve and how it will do so?
Yeah, so that study was focused on measuring the interaction between the human and the spacesuit using wearable sensors. Spacesuits, the ones that are used today, are gas pressurized. So they're like a big balloon, which makes them quite stiff, which makes them very difficult to manipulate. And so the force that it actually takes to manipulate the suit to do different activities can in and of itself cause injury. And so in that work, we were trying to develop sensor systems that could fit in a garment underneath the suit that could detect the pressure between the human and the suit, and the positioning of the body within the suit. And that work is actually ongoing at CU Boulder, where I did my PhD.
All right. So what is the goal in creating spacesuit instruments that will collect data about what's going on in the human body in the environment out in the space?
Yeah, so the human body and the mind are both under extreme stress when in the space environment, physically and psychologically. So there are many different factors that can affect a person and affect their performance and cognitive ability, and their overall health. So being able to monitor more of the signals that the body produces in real time has the potential to prevent injury and potentially prevent severe mental health repercussions as well.
So what is the purpose of investigating bioelectrical potentials of a human body?
Yeah, a lot of different purposes for this, this type of sensing, but the electric potentials that can be detected on the human body really offer us a window into what's happening with different organs that in turn allows us to monitor physical and psychological health. So it's sort of a window into these internal processes that are quite hard to measure otherwise. So for example, the heart produces electrical signals during each heartbeat. So each time you feel your heart pulse, it's producing electrical signals to do that. And those signals can be collected using electrodes that are mounted on the skin. And then from those signals, we can measure if someone is, say, exerting themselves way too much physically and going to cause problems that way, or if it's something like they're not getting enough sleep or not getting the sleep quality that they need to. So you can actually tell quite a lot from just someone's heart signals, usually called electrocardiogram or ECG or EKG. So really these signals offer a ton of information that can be collected pretty easily. And this is something that of course has been done for a really long time by physicians. But it's cool that it's now sort of moving into the human spaceflight environment.
So what has been your toughest accomplishment so far in your career?
Yeah, that's a good question. I thought about this for a while. I think for me, the toughest thing was getting the funding to pursue a PhD. The really tough thing about research is that in order to do the research that you want to do, and in aerospace engineering and really in all areas of research, you have to convince someone that your ideas are valuable enough for them to be willing to fund your research. So I started graduate school as a master's student and was looking for opportunities to find PhD funding. And most of those opportunities at that point are fellowships that you can apply to by writing a big research proposal with all the details of your work outlined. And so I submitted 8 or 9 of those over 2 years while doing coursework and research and TAing classes, which took a ton of work and perseverance. And I had to definitely pick myself up and keep applying after getting rejected so many times. And that was really a huge challenge. So definitely that was the toughest so far.
So what's a big milestone that you're looking forward to in your research?
Yeah, right now I'm working on bringing some of the physiological monitoring principles that I worked on mostly in my PhD to the area of human-robot interaction. So the exchanges that happen between humans and robotic systems that when they're working together, which is sort of a new area to me. So I'm really excited to see how these experiments go and what we can learn by sort of bridging these two focus areas.
And lastly, to high schoolers like me and to younger generations that want to become aerospace engineers, what would your advice be to be successful in this career?
My advice would be to take criticism in stride and try to learn from every piece of negative feedback that you get to make the next thing that you do even better, because there is always a ton of constructive criticism and often negative commentary that you get. And so it's important to try to figure out how you can grow from all of that. And I will say that it's important to ignore the people throughout your career that let their own bias get the better of them and say that you don't look like an engineer or something. I think it's really important to acknowledge that will happen and learn how to move past it.
Well, thank you for joining me and thank you for letting me interview you, and have a great rest of your day.
Thank you.